So now that we've done a very quick example of hash-based sharding, what's it good for? What are the benefits? It's very good at right scaling. A well-distributed and balanced hash-based shard key is going to randomly distribute your writes, and you're going to have an even distribution of chunks across your shards, and therefore you're going to evenly distribute your writes across all your shards. So if writes are your scaling factor, if that's why you've gone with sharding in the first place, then hash-based sharding on a particular collection may be the way to go. Drawbacks. Well, when discussing how to pick a shard key, one of the things that we mention is that having good data locality for range-based queries can be particularly efficient and beneficial. A hash-based shard key will, yes, very evenly distribute your writes, but it'll also very evenly distribute any non-specific read. So if you're querying for more than one document, all of your read queries will be essentially scatter-gather. Unless you're going for one document, in which case it will just look that up in the shard key, direct it to the correct shard. More than one document or any range-based querying that you do will be scatter-gathered. It'll have to hit all of the shards. So you can imagine you've got your MongoS, you've got your shard 1, you've got your shard 2, you've got your shard 3, and all your writes here in red are being nice and evenly distributed, which is great. You're getting great write scaling, that's fantastic. But when it comes to reading back off of these shards, when you do a range-based query across your data range, it has to hit them all. It's going to be a random distribution of reads here in green. And that may or may not be a problem for you, but one of the things about scatter-gather type queries is that, first of all, the final result as aggregated by the MongoS here, you remember we talked about one of the functions of the MongoS that it actually does is it will merge and then merge sort, if necessary, result sets and feed them back to the application. It's going to have to wait for the results from all three shards to actually do that work and send it back to the client. So any read that you execute will only be as fast as your slowest shard. So this is a very common sort of complaint when you're distributing reads and writes across anything. The other drawback is that it is single field only at present. So if you need to have multiple fields to do decent queries on your data set, this might represent issues for you. So for single field targeted queries and for someone who's scaling their writes specifically, then hash-based shard keys do work, but please bear in mind some of the drawbacks. Finally, the last drawback. Hash-based sharding not supported when you're using tags, which kind of makes sense. It would be very difficult to break up this sort of random distribution. This is a computed hash, remember. Your ranges are going to make no sense whatsoever, and tag-aware sharding is all about breaking things up into logical groups, pinning them to particular shards or sets of shards, and tagging the ranges appropriately. If you tagged a range of computed hash values, that could be all over your data. So there's no good way to do that. The only thing you could use tag-based sharding with hash-based sharding is to pin an entire collection to a set of shards. That's it. So you can't use it for the generic tag-aware sharding. Hence, we say that it's not currently supported.